Hey everybody, today I'm going to have you learn how to solve for percent error, and we are going to use some real world data from the snowstorm that we just went through. So before we left for the weekend, I asked all of the staff faculty at Bernheim to submit their guess for what our precipitation would be for the storm. I did specify that it had to be what would be recorded at the airport. That way everyone had the kind of same point of reference. And we're going to look at two staff faculty guesses and compare it to the real amount to see what their percent error was. So some things you need to know. Percents are always out of 100. We've talked about that in class before. Cent means 100. There are 100 cents in a dollar. There are supposed to be 100 feet on a centipede. So percents are always a ratio out of 100. When we're talking about percent error, that means we're looking at the ratio of the amount of error to the correct amount. So since there was actually 5.9 inches of precipitation, that's going to be the bottom of all of our ratios. Now, for our first guess was Miss Ackerman. She guessed 24 inches of snow. She said there's going to be 2 feet. So first, let's find our error, just the amount of error. So we know that the correct amount was 5.9. So we're going to do 24 minus 5.9. And that gets us 18.1. And that's going to be out of the correct amount, which is 5.9. So now we can look at that ratio, 18.1 over 5.9, and say, well, what if it were out of 100? Okay. I think the easiest way to do that is using a proportion. So I'm going to set up the correct amount or the whole amount on bottom. And then our error goes on top. That was supposed to be a blue pen. All right. So we need to figure out if we make our fraction bigger so that the bottom number is 100, but we keep it an equivalent fraction, what would the new numerator be? The easiest way to do that, in my opinion, is to first divide, do 18.1 divided by 5.9, and that's going to get me a number close to 3 because I know 18 divided by 6 is 3. And that will tell me kind of the relationship between the top and bottom numbers, right? I will know that the top number has to be about 3 times bigger than the bottom number. When I divide that out, I'm going to get 3.0677. It actually keeps going quite a bit after that, but we need to go this far. 3.06779, we'll go that far. Now I know that that's how many times bigger the bottom number has to get to become the top number. So then I can take that and multiply by 100. So I'm going to take 3.06779 and I'm going to multiply by 100. And what that will do for me is essentially slide my decimal over twice to get me 306.779%. And for the sake of your assignment, I'm going to have you round to the hundredths place, so that's that second 7. We would say Miss Ackerman's error is 306.78%. So there's our first percent error figured out. Next, we will calculate Mr. Bixler's percent error. Okay, Mr. Bixler's pretty silly. He said his guess would be 17.314159. So we need to figure out first what is the amount of error. So we're going to take his guess, and I got to squeeze it in at the top of my fraction. 17.314159 minus the correct amount, which was 5.9. And we're going to find out what the amount of error was. And that's going to get us 11.414159. You'll note I'm getting some pretty lengthy numbers. I'm not going to round until I get to the very last step. So the amount of error was 11.414159. I'm going to put that on top of my fraction. And now I'm going to do the same thing as before. I'm going to divide going down to figure out the relationship between the top number and the bottom number. Now, I know 11 is close to 12. 5.9 is close to 6, so I know that the top number needs to be about twice as big as the bottom number, right? My numerator is about twice as big as my denominator, so I know when I'm done, my percentage should be close to 200. Not exactly, because we've got all these decimals, right? But it's good to think about what would be a logical amount. So we're going to divide all of that by 5.9, and that's going to get me 1.93460, and that gets me there's a couple numbers after that, but this is all I really need. Okay, so now I know I can take that bottom number times 1.93 and get to the top number. So what am I going to do? I'm going to keep on trucking. I can just stay in Desmos and type in times 100. So when I do that, that moves my decimal over, boop, boop, and it becomes 193.46, and then I want to round to the hundredths place where that 6 is. The 0 next door says keep it the same. So Mr. Bixler had 193.46% error. So he was wrong, but he wasn't quite as wrong as Miss Ackerman. So you're going to take all of the data from our guesses and you are going to calculate the percent error for each of our staffulty members and figure out who was the closest. If 2 staffulty members guessed the same amount, you do not have to repeat the steps. You know the answer, so you can just type in the answer. You can either use scratch paper or you can use Canva like I've done here. If you just go to canva.com, there's an option for a whiteboard, and that's pretty easy to use. If you've got any questions, as always, let me know.